work on some practice. So today, angle side angle, ASA, and angle side, AAS. These are two new shortcuts. You can probably guess what they mean based on what we did yesterday, but I'll talk through them here. Angle side angle. So notice where the S is here. This is saying you have two angles congruent, and the side is included between the two angles, and it's congruent to two angles and an included side in another triangle. And if you have that, then the triangles are congruent. So this is included. Two angles, included side, congruent to two angles and included side in another triangle, then the triangles are congruent. So I should probably talk about this word. I said it there, but included side, it's a side simply formed by two angles. So if we look over here at angle R and angle T, if we look at those two angles, the side that is between them is this one, RT. So yesterday we had included angle, today we have included side. And here's a little diagram as well about how that should look. Now, if you do not have an included side, it actually still works, but you're going to call it angle side. So if you have two angles congruent between triangles and an excluded side, basically a side that's not between the two angles, it still works. So I said two angles and a non-included side of one triangle are congruent to the same, the corresponding two angles inside of a second triangle, and the triangles are congruent. Yeah, it's this. This one's that one's angle side. This one's angle side angle. You do have two triangles, but I'm just saying this one there's two angles. The side is just not between them. The side that you know is congruent is not between the two angles. Between the two angles. Hey, I wanted to say that which one? Oh, here, this one. Do you know this one actually works? It's just it's just because angle side angle. So if you had two triangles and you knew, here I'll do angle side. Okay, you knew this. The reason this one works is because if you have two angles congruent, then you could say the third angle theorem, right? That these would be congruent, and then it's angle side angle. So you actually never actually need this one. It's you could always just do, if you had this set up, you could do the third angle theorem and then it would be this one. But it's easier just to do this. This is shorter. Okay, thoughts on those right now? The two new ones? Yes?
Wait, I don't know. Why is that one shorter?
This is shorter because, okay, so say we didn't have this. We didn't know that was one that works. Well, if we had that set up, two angles and a side not included, we'd have to take an extra step and say third angle theorem. We have to say third angle theorem that these angles are congruent. Then we would have angle side angle right here. So you basically got to take an extra step, third angle theorem, and then you would do angle side angle. So having this, it just saves you one step. That's pretty much why it's helpful. Yeah, Maddie?
So what's the difference between the two triangles?
These two?
Yeah.
What the side is. Here the side is between the two angles. It's that side right there. It's between the two angles. Over here, there's the two angles. The side, it's not between the two A's. It would have had to been this one to be angle side angle.
But they look the same.
The two A's are the one A.
Oh!
Yeah, where the S is though is different. Here's the S. It's not between the two A's.
I didn't even see the letters.
Here the S is between the two A's. Yeah.
Did you say side angle?
Oh, what a great question. Yeah, you guys, man, good questions there. Yeah, this is the first time we've seen one. She said, could you do SAA, side angle angle? Technically, yes, but you're never going to see that. Like if it was a state test, and options, they wouldn't have this one. They would just say angle, angle, side. So technically, yeah, I wouldn't count that wrong if you said it.
Oh, okay.
She just turned it around. Yeah, you could say SAA. It's just you won't really see that one. Every other one so far, if you turn it around, it would still be the same thing. SSS or SAS or SR. Good question. Man, anything else?
I mean,
Right now? Well, we're going to do some examples. Now, before we do some examples, this is always fun. There's been 3 letters for all these, right? Angle, side, angle, SSS. There's 2 combinations of those 3 letters that we haven't used yet. They don't work. So first of all, let's identify what they are, and then I'm going to tell you why they don't work. So what's one combo of the letters? Can I think of it? Yes, angle, 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 AAA. Does not work. First of all, I'll say this. I always think AAA is the car company or whatever that comes with, you know, look at your stuff. AAA? So in this case, AAA will not come to rescue you. I always say that because it's not one that works. So you can never write it as a reason. You might think why. Just tell me like. Yeah, so this AAA would say, hey, I have 3 angles congruent in a triangle, congruent to 3 angles in another triangle. But that doesn't work to show the triangles are congruent. They would not be congruent. I'm asking why. Why would AAA not work? You could say one word or the short explanation. Why?
Well, if you have like an isosceles triangle with an equilateral triangle, and you have a solid,
But that'll only be 2 angles versus 3. So what are you thinking, Brian?
The sides can be longer and everything.
That's it. Yes. In the simplest form, different sizes. Simplest form. Thank you. So here, it could be equilateral, isosceles. I'll just draw. I'll draw that triangle. Okay, so I cloned it. I made it a congruent. First of all, it's congruent. Then I changed the size. So the angles are still the same. Those angles are exactly the same that match up. So those triangles certainly will have 3 congruent angles, but they're not going to be congruent. No, they're different sizes. We would say they're similar. So you can, AAA does work to show triangles are similar, but not congruent. Anybody think, so thank you. Can anybody think of the other combination of letters we didn't use? Audrey?
SSS. Wait, no.
No, we did
that
SSS.
yesterday.
Yeah. That is correct. Now, here's what I read because I don't want to, I don't want you to have to actually write
It's
that.
right.
down.
SSA, but
Yeah, SSA is how the state test would. It would be a wrong answer, but SSA or ASS. I put at $, just so you don't code.
just in case
You
not
like to do that,
Code.
Just write the word.
So I'm going to write over here SSA. That is the one that doesn't work. Think about it because you can't write that. You can't write it backwards, SSA. I will show you why this doesn't work later in the year. Actually, there's not a good way for me to show it to you right now. Once we have more things, I can show you why it doesn't work. Oh, I already did that. Okay. So I think I had a little spot down there for you to show why angle, angle, angle doesn't work. You could just, I just did 2 triangles. Or just write the words different sizes. Or you could draw 2 different triangles, two similar triangles, but they're different size. Okay, I want you to try those pictures again, just like yesterday. So now you have 4 choices. You can use ones from yesterday. Yeah, there's more choices now. So, are the triangles congruent? If you think so, write SAS or side, side, side. The new ones are a SA or AS. You could also say none. It says if any. So they might not be congruent. And you'll write no. All right, just take 1 minute.
Oh, fuck it. Why are you laughing at me?
You're funny.
Oh, thanks.
I don't think I've ever heard somebody say that word when you're upset.
I'm funny. I'm so funny. Wait, these are, I hope I don't let you know this. I don't understand this stuff. How do you know? I accidentally told so many groups I really don't share. I don't know.
Just do your best. I want you to write something down.
I would say,
Think about what's provided.
that's the same shape.
I'll go with it.
Oh, shoot. Okay. Oh my god, I gotta get
Yeah.
that.
Okay, let's see how you did. On A, what did we put? Michaela said she wants to do that. That was good. Go hand raise. Oh, you got it. What'd you put for A?
I actually skipped
Julie, want to help her out? I mean, go take a guess if not. One of you guys. SAS? Okay, well, there's only one side marked, like here, one pair of sides. So actually, like, you can kind of eliminate that because those two, because those need 2 or 3 sides. Ashley, you want to try it?
Angle side angle.
Angle side angle, right? Isn't this one ASA, like 2 angles and the sides in between? But the other one, you're right. This one would be angle side angle, but that one, the side is not between. So what should it be? It should be none work. They have to match up. So you see how that right one, the side would have needed to be there, then you would have been right. Hopefully in B, I'll help you out a little bit here. Did you mark that the vertical angles were congruent there?
Oh.
Then, Zane, what'd you say?
AAS.
Very nice. AAS.
Oh, yeah.
There are 2 angles marked congruent, and the side is excluded. It's not between the 2. C, guys, you could have had any of them. I'm just going to just write the word any. You could have had any of those because, except none. Because these sides are both 4, and that's a reflexive, you would then have all 3 sides and all 3 angles. So you could put any of the 4. You could even put definition of congruent triangles since you have all 6 points.
But don't put A.
Correct. You could never write AAA or SSA. There are, but that's not a way to show triangles in Europe. You're right. Even though there are, congruent triangles must have 3 pairs of congruent angles, but you can't show they're congruent by A. Last one, what'd you put? Ryan?
Put it none, but then I put it also could have been angles.
Well, you gotta write, the third angle theorem shows angles are congruent. You want to show triangles are congruent here. The answer is none because it would be AAA, but again, there is no AAA. Now here, for a second, I want to stop. Guys, I have put a question that was AAA on a test before. I think it was a different diagram, but similar to this. 3 angles marked and 3 angles. No sides marked. And I've had students in the past put like SAS on this one. it kind of boggles my mind because you have to have it marked. There are no sides marked congruent, right? So you can't. Every single one must have at least one side. There are none marked, so you have to have a side. There are none. Okay. Can we move on? Any questions on that one?
No.
Okay. Don't set up the proof because we're gonna do a flowchart proof on this one. So when you look at this proof that we're gonna do for today, everything we've been doing the past couple of days has been, hey, show two triangles are congruent. This says show the sides are congruent. That's a little different. Well, if the triangles are congruent, so if we can say triangle WRL and DLE are congruent, that means the three sides and angles are, right?
Yes.
So that certainly would be. So if you are in this unit and if you're trying to show sides or angles are congruent, here's what you're going to do. You're first going to show this. The triangles are congruent. And then you're going to take one more step and say the sides are. So yes, it really is still a triangle proof, showing the triangles are congruent. But then you'll take one more step. I had a slide here that said that. I said, what if it wants you to prove the sides are congruent or angles? And I said, first show the triangles are congruent. Then if the triangles are congruent, all the sides and angles will be, you'll put CPCTC. Okay, I thought we haven't done a flow chart. Let's do that on this one. Each given is its own box or circle. And I'll mark it on the diagram as well. We're going to show the triangles are congruent, and then those sides will be. Okay, so first box, L, is the midpoint of WB. Well, I'm going to go down. You can go down if you want. You might go right a little small or go across. Do you remember we read the reason below it here? Yeah. Okay, and then every given is separate, right? So WR, it's a separate box here. WR parallel to EB. Given. And if you ever have to bring in something else from the diagram, then that will also just be a separate box. What's nice about this, I thought this was a perfect flowchart proof because you start with your separate givens. They tell you something directly, and then all of them together, you'll put three arrows coming together to say the triangles are from there. Because they all work together to show that. Okay, so first one, L is the midpoint just of WE. We don't know it's the midpoint of DR, but it is the midpoint of WE. So that says these are congruent. WL and EL. Draw an arrow, then the new one you put a box. I marked it on my diagram, please do that. And then below, so if you put definition of midpoint, I'd be okay with that. It's technically midpoint theorem. Okay, it also says WR is parallel to ED. So this is where I said earlier, if they say they're parallel, you can't say they're congruent. Parallel lines don't have to be congruent. They usually are not. Okay, but we saw it in that number 9 practice a few minutes ago. If you have alternate, I said it backwards. If you have parallel lines, do alternate interior angles. So if these are my parallel lines, I can actually choose either transversal. So if I choose this one, it's going to be those two. Now I'm going to make it easier. We can name them with one point. Right? I can name it angle R. You can say WRL if you want. I crossed this one. What is that a D?
Yeah, it's a
Okay. R congruent to D. Oh, alternate interior angles Now we really have two choices here. You remember I said they're bow tied and we can do vertical?
Yeah.
That's some. So we could do vertical. We'd have to introduce another box here. Or we had parallel lines. This is a separate transversal, and these two would be congruent because they're also alternate interior. So which one do you want me to do? Like keep alternate interior? Well, it's just it doesn't matter. If I do alternate interior, I'm gonna have an arrow coming from here. And I'm gonna say W and E. If I choose to do vertical, I'm not gonna have an arrow. And I would just say this angle and this angle, vertical angles. You want to do vertical? Okay, sure. It doesn't matter. It basically just the arrow is the only difference. So guys, again, if you wanted to, I'm gonna erase it on here. We could have done those two are alternate interior as well, and those would be congruent. But that's fine. We'll do vertical angles. So those two are going to be congruent. I'll try and fit it in here. Angle WLR. It's a W. Congruent to angle DLE. So this was what I was saying. It's just it was kind of from the diagram. We can say any two vertical angles are congruent. So there's no arrow coming from parallel or anything. It could have been one we started with as well. Vertical angles thing. Okay, Ryan, go ahead. No. We actually have enough information. You could do third angle theorem, but we don't need to. If the reason is because we have two angles and a side, and we have a postulate that says the triangle is congruent.
What does that say?
Vertical angles theorem?
Or in the box?
It's naming these two, WLR and DLE. I'd already drawn a box, didn't want to erase it. Alright, so here's where we have enough information because I marked my diagram. I have what? Two angles and a side. Two angles and a side. This side is not between the two angles. So it's going to be AAS. And here's where I like the flow chart. It comes together. All of these three work together to show the triangles are congruent. I guess I can just use a WLR congruent to triangle DLE. They all work together. The triangles, I said, what? Angle, angle, side. Normally we'd be done, but they want us to say one extra step that the sides were congruent. And since the triangles are, it directly means that those sides are congruent. I don't know what they are. WRED. Yes. Now I'm going to write CPCTC. Corresponding parts of congruent triangles are congruent. You could also write definition of congruent triangles, but I think state test, they would write this for like the end of a proof. Yeah, I want to say one other thing about this one. If you were doing a 2-column proof, givens, of course, are step 1. You could in the same step. Any of these interchangeable, steps 2 through 4. So like this could be step 2, this could be 3, this could be step 4. But it's interchangeable. Any of those. Then this would have to be step 5, and this would be step 6. Got any questions?
So what is CPCTC?
It stands for corresponding parts of congruent triangles are congruent.
So like, how do we show that in the like picture? Like, what does that mean?
There's nothing to mark in the picture. It just says if it's the definition of congruent triangles. It says if the triangles are congruent, then all six parts, the 3 sides and 3 angles are
Oh,
congruent.
so like all sides of okay.
Yeah, it basically just says all the sides and angles are congruent. Yes, that's
Congruent.
Nice. Any other questions?